Alright guys, this is lesson 63 and we're going to go through the lesson practice. Make sure that you have read page 405 through 407 before you start this lesson practice. I want to make sure that you work with me on a piece of paper so you have examples to help you through the written practice. So we're going to start with letter A. It says, draw an example of each of these polygons. Okay, so we're going to go with a triangle here. So this here is a triangle, and I tried to make it where all the sides were equal, and I'm going to mark that by putting this little line here. And this would be a regular triangle, or an equilateral triangle. Equilateral. And you could do one like this, where it just has two equal sides, and that's called an isosceles triangle. And I always have difficulty spelling isosceles. Let's see here. Let's go ahead and we'll type isosceles, just in case I don't spell it right. Isosceles. Nope, I didn't spell it right, so I'm going to double check my spelling. There we go. That's an isosceles triangle. And then we have a triangle that has all different sides, and that's called a scalene triangle. Alright, so you can draw one of those. B wants us to draw a quadrilateral. And a quadrilateral is a four-sided polygon. So there are lots of examples for quadrilaterals. I could do a square, and I'm going to show that's a square by marking it because my artistic skills aren't that great. You could have a rectangle. The sides equal and these sides are equal. Or you could do like a rhombus. Or you could do something wonky like that. As long as it has four sides and it's closed. Trying to close that there. You could have a parallelogram. And a parallelogram is kind of like a rectangle. It has equal sides opposing. The difference between a parallelogram and a rectangle is a rectangle has right angles in it. Parallelogram doesn't. Alright, let's go ahead. Any of those would work for a quadrilateral. And what's this draw? A pentagon. Well, a pentagon is a five-sided shape. It doesn't say it has to be regular, so we're just going to draw 1, 2, 3, 4, 5. So we got 5. And if all those sides were the same, that would be a regular pentagon. We'll pretend they are with my drawing, but I could draw something like this: 1, 2, 3, 4, 5. And those are supposed to be straight lines, but it's not regular, obviously. A hexagon is a six-sided shape, so we're going to go 1, 2, 3, 4, 5, 6. We'll try to make that connect there. And we'll pretend that this one is a regular hexagon. All the sides are equal. And we could do one that's not all equal. There's 1, 2, 3, 4, 5, 6. So that's an irregular hexagon. An octagon, you guys might be familiar with this shape. It's got 8 sides, and if they were all equal, it would be a regular octagon. I'm going to show that by marking them like this. Or I could do something wonky like 1, 2, 3, 4, 5, 6, 7, 8. That would be an irregular octagon. A decagon is a 10-sided shape, and I'm not going to be able to draw that regularly with my pen yet, but as long as it has 10 sides, we're good. Where's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 sides. This is an irregular decagon. A regular decagon would have 10 sides that were all the same length. G says, name each polygon shown and describe its angles. Okay, so our first polygon, let me make sure I'm on the right page here. Yep, we're still on page 407. So this has 4 sides. It has 4 sides. So it would be a quadrilateral. So a quadrilateral quad is that 4 parts. That means it has 4 sides. It's quadrilateral. And in the book, they look like they're all the same size. And it says to name its angles. Well, this looks like a rhombus or a rotated square. And we know that those have right angles in the corners. So the angles are right angles. That means they're 90 degrees. Right angles equals 90 degrees. All right. This says name each polygon shown and describe its angles. Well, let's count the sides here. We've got 1, 2, 3, 4, 5, 6 sides. There's 6 sides. So that would be a hexagon. A hexagon. It's an irregular hexagon. All the sides aren't equal. And it says to name its angles. Well, this hexagon is made up of 2 rectangles. And rectangles, we know, have right angles. So these are right angles. All right, let's go ahead and go to J or I. Is this in here? Let me turn my page real quick. This is I. And we're going to start by counting the sides so we can find out what polygon this is. This is a 1, 2, 3, 4, 5 sides. So a 5-sided polygon is a pentagon. And then it says to name its angles. Well, on the top we have these right angles. So right angles. And we also have these angles, which are not right angles. And these would be, they're more than 90 degrees. They're wider than a right angle, so they would be obtuse angles. Obtuse. So I'm going to write and. All right. And moving on to J, it says name each polygon shown and describe its angles. Okay, we've got 1, 2, 3, 4, 5, 6, 7, and 8. An 8-sided polygon is an octagon. And all of its angles in this picture are wide angles. They're more than 90 degrees, so they're obtuse angles. All right, moving on to K. Which figures in problems G through J appear to be regular polygons? Well, we know that regular polygons have equal sides. All the sides are equal. Well, I can see right off the bat that this side is not equal to this side. So this is not a regular polygon. And again, this one here has different length sides. So this is not a regular polygon. However, this one here has, it's a rhombus, and it has 4 equal sides. So this is a regular polygon. So we're going to write G for our answers down here. We'll write G. This is a quadrilateral. I called it a rhombus, but the book doesn't say the sides are equal, so these may not be right. But we know that that one, I'm pretty sure it is. So this is a quadrilateral. It means that all the sides are equal. I can tell by looking at it. And then this one over here is J, and I didn't draw it very nicely, but in the book it certainly appears that all the sides are equal. So we're going to go ahead and write J for the octagon. So these two are not regular because they don't have equal sides, and these are because they have all equal sides. What common street sign has the shape of the polygon in problem J? What if I colored it red? Making it red for you. Does that give you a hint? No. What if I wrote, let's see here. Let's go ahead and go to the white color. I'm pretty sure that's what color they are. And I wrote an S here. Does that give you a hint? I don't know why it's not going. What about if I wrote a T O P? Not the best art in the world, but I'm pretty sure you guys get it. It is a stop sign. So you could write a stop sign. I'm going to write exclamation point. That's the answer for J. And then for lesson, or for question M, it says a decagon has how many more vertices than a hexagon? Well, a decagon has 10 sides. That's what deca means, 10. And a hexagon, messed up there, a hexagon has 6 sides. And it says, how many more? Well, that's a key. That means we're going to be subtracting. So we could just do 10 minus 6 equals 4. So our answers would be, oh, I messed up. So that was sides. When you draw a picture like this, these are the sides. But with these corners here are the vertices. So vertices is another way of saying corners. And luckily, the decagon has 10 corners, or 10 vertices, and the hexagon does as well. So we'll change these to vertices. Good thing I double checked the directions for the question. So 10 minus 6 equals 4 vertices. So the answer would be 4 more vertices. Circle that. All right. So that is all of lesson 63's lesson practice.